Hello everybody. So what we're going to be doing today is graphing tangents and cotangents. And this is my second try at this because I tried to make this lecture earlier and then instead I made a 45-minute video on graphing sines and cosines, which will be uploaded after that assignment was due. But, well, still useful. Anyway, let's get to this. So what we're trying to do is plot tangent first of all, right? So we're going to do tangents and then we'll do cotangents and then that'll be that. So we're doing tangents. So you want to plot y equals tangent x, right? And in order to do that, you want to remember that the tangent is actually the sine over the cosine. And you also want to know, well, not also want to know, you just want to remember that the tangent is sine over cosine, because if the tangent is sine over cosine, you've got a denominator, cosine, and the cosine is 0 sometimes. And so when the cosine is 0, you've got to divide by 0. So let's see. There is a divide by 0 problem at, well, what x values? So any x value where the cosine is 0. So that's actually plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. So basically all the odd multiples of pi over 2. Okay? What that does on the actual graph of this function is this. So if I plot a tangent here, what happens is, let's just say, let me get a different color, a lighter color. So let me just say that this is pi over 2, and this is negative pi over 2. So 4 boxes is pi, I guess. So 1, 2, 3, 4. This would be 3 pi over 2. 1, 2, 3, 4. This would be 5 pi over 2. And this way, 1, 2, 3, 4. This would be negative 3 pi over 2, and that's probably as far as I'm going to plot this. There you go. So those are the places where we have a divide by 0. Now, if there's a divide by 0, what happens is that the graph becomes infinite. And so if I draw these in, these lines here, sorry, this will take a minute here. I wish there was a draw a dotted line feature in here, but I don't know about one. Okay, so we have these lines here. Now what happens to the tangent graph is in each of these sections, exactly in the middle of this section, the tangent goes through 0. And then on this side here, halfway in between there, it's up at 1. So I'll call that 1. And on the other side, halfway in here, it's down at negative 1. And in between, what it does is this. So it's kind of got what should be a 45-degree angle, and then it curves up, does that. Same thing down there. And that's what it does. And then it just does the exact same thing in every one of these boxes. And we're going to come up with these values in a minute. So it's not like this is going to be our only exposure to them, but I just wanted to get the picture drawn for you as soon as possible. And then let's just draw this last one. Oops, I didn't put these points in. Okay, so there's some pictures of a tangent graph. All right, and you want to be able to draw that as well. And so the easiest way to do that is to think about this way. So one period of the tangent graph looks like this. So I'm going to take just x and y here. And so if I write negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2 for the x-axis, and then for the y-axis we're going to do y equals tangent x, then here you've got tangent negative pi over 2. But look up here. This is one of the values that I told you was going to be a divide by 0. So those are the asymptotes. So this one does not exist. Okay? Then the next one is pi over 4, and you have tangent of pi over 4, negative pi over 4. Now on the unit circle, right, you would normally do this on the unit circle for calculating these things. Here's a circle. Oh, come on. That was enough of a circle. Okay. Normally, like on a unit circle like this, so negative pi over 4 would be negative 45 degrees, so it's down here like this. And the coordinates would be, what would they be? They would be positive square root 2 over 2, negative square root 2 over 2. And when you divided those, right, because tangent sine over cosine, so y over x, you would get negative 1 because they're the same value, but one of them's positive and one of them's negative. Tangent of 0 is 0, sine over cosine. Sine 0 is 0. Tangent of pi over 4, pretty much the same as what we already drew, except it's up here. That one comes up 1. And when you do pi over 2, that's straight up here, pi over 2, 0, 1. So when you do y over x, you have a divide by 0 again. So that's another does not exist, right? And so the vertical asymptotes, right, these are the divide by zeros. So like this is a divide by 0, or D and E in my graph over here, for those. All right, and then in between there's only 3 values to look at. Well, I mean there's more than 3, but the 3 that we want to get in the right place are these 3, right? And those are this one, and this one. And so really, if you think about it, if you can just get those in the right place, if you know where the asymptotes are and you get those 3 points in the right place, then don't you have a graph of a tangent? You do. So it's really pretty straightforward. Okay, so let's look at kind of a generic tangent now with like stuff changed. So suppose we have this. So let's say, what if we want to plot y equals a tangent bx. So I'm not adding a phase shift or anything yet. I just want to plot a tangent bx. Well, what is that going to do? Well, the first thing is that the period's going to be different. Okay, so normally the period, normally the period of the tangent is pi over absolute value b. Now you probably remember the previous lecture, or previous 2 lectures, where we did the period of a sine and a cosine, and it was 2 pi over b, right? But that's only for sine and cosine. The period is 2 pi over absolute value b. The reason it's 2 pi over absolute value b for sine and cosine is because the sine and the cosine repeat themselves after 2 pi, normally. But if you look at this graph up here for the tangent, you can see that this distance from one asymptote to the next asymptote is only pi, right? Not 2 pi. So that's the natural period of the tangent function, and then the b, when you add a b right here, that adjusts it. So pi is the natural period of the tangent, and the b adjusts it. Okay? So you have the period. Now, there's no amplitude, okay? There's no amplitude. Why? Because the amplitude, remember, was by definition 1/2 of the maximum minus the minimum. And this has no maximum and minimum because it goes up to infinity. No maximum, no minimum. So no amplitude, right? So the B tells you the period, okay? From there, what you're going to do is you're going to say, well, that means that you have vertical asymptotes at what points? Well, so they're at x equals the first one, like when the period is pi, the first one's at pi over 2, right? So that's half a period. So that's going to be at plus and minus 1/2 period. The next asymptotes are going to be plus or minus 3/2 periods, right? 3/2 pi, remember? That kind of thing. And then that pattern is going to continue. So plus or minus 5/2 period, ... Okay? So you get those asymptotes in the right place. Okay? Then what you're going to do is I'm going to recommend that you do this the way that we did the graphs in the previous lecture as opposed to 2 lectures ago. So what I'm going to say is that you should do this. We should make a table now. So in your table, here's what you're going to need. So you have your x values and your y, which is a tangent bx. So your x values, what you want are negative 1/2 period. Can I just put a P for period? Is that going to make sense to you? I think so. Negative 1/4 period. 0, 1/4 period, 1/2 period, right? And then the y values, what you got to do is the first one, there is not a y value there. This is where the vertical asymptote is. Okay, so there's no, that's D and E, right? Maybe I should have written D and E. Same thing for the last one, D and E. All right, now in the middle, the basic graph went -1, 0, +1. Well, if you add an A here to the front, it goes -A, 0, +A. I shouldn't say plus A, just A. And that's it. That's one period. And then if you want to repeat the graph, you can repeat the graph as much as you want to get multiple periods plotted. So this is not that bad to plot, honestly, right? Like if I say example, plot, and I want to plot y equals, let's say 3 tangent 3x. Why not? 3 tangent 3x, right? All you need to do is you should just calculate the period. It's going to be pi over b, not 2 pi over b. So what's the b? 3, right? There you go. That's your period. Now, from there, honestly, you can go straight to making the table because the table is pretty simple here. So you have your x and y equals 3 tan 3x. So your x values are going to be, what do we say? Negative 1/2 period. So negative 1/2 period. I put that wrong. What's the period? The period's pi over 3. So what's that work out to? Negative pi over 6. Then negative 1/4 period. What's that? That's negative pi over 12. Then 0. So 0. Then you have 1/4 period, which is going to be positive pi over 12 in this case. And we got a 1/2 period, which is going to be pi over 6. All right. Now, for your y values, just get your y values again from this. So the first ones, actually, they're not points. Those are the vertical asymptotes. They don't exist. In the middle, it's just negative a plus a. So a is 3. So that's negative 3, 0, 3. So there we go. So how are you going to plot this? So you make some axes here. Put some marks on here. So we need like pi over 12s marked. So let's call this pi over 12, pi over 6, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, negative pi over 12, 2 pi over 12, that's pi over 6, 3 pi over 12, 4 pi over 12, 5 pi over 12, negative, negative. Okay, that's going to be enough for me. That's enough points plotted. Okay, wait, one more, sorry. Negative 6 pi over 12. Okay. Now that's good enough. Now, that's going to be a very small graph. All right, so what we got is our first points, right? At here and here, those are the ones where we have vertical asymptotes. Now look at the x values. That's pi over 6 and x equals minus pi over 6. So mark those asymptotes, okay? So mark the asymptotes. So negative pi over 6, positive pi over 6. So here's the pi over 6. Right, pi over 6. Negative pi over 6 is negative 2 pi over 12, so that's over here. Now, in between, you've got, what are we at? We have this point, pi over 12, negative pi over 12, negative 3. Then we got 0, 0, and then pi over 12, 3. So you plot those. So negative pi over 12, negative 3. So I need negative 3. So where's negative 3? I guess down here. Right? If that's a negative 3. Right there. Then I got 0, 0, which is right there. And then I got pi over 12, positive 3, which I guess is right there. Right? Now this is going to look very stretched out because of it's kind of tall here and skinny. But it goes through this angle, or it goes through the origin with an angle. It's not like vertical, it's not horizontal. And then it needs to curve up and go through there, and it needs to, well, it's actually kind of not drawing it very well here. Try again. I need to erase some of this. It needs to go through here and then keep getting closer to that asymptote, so I have to be careful about how I draw that. It's very stretched out, this one. Okay, and that's your graph. That's one period. If you want to draw another period, you just repeat the pattern. So like I got like 4 boxes between like 1, 2, 3, 4, right? 1, 2, 3, 4 boxes between asymptotes. So do it again over here. 1, 2, 3, 4. Here's the next one. And then what's it look like in there? Well, it's easy to copy the pattern, right? Halfway in, you have a dot. And then you got a dot there. You got a dot there. Kind of. Like that. Okay? And there's 2 periods of that particular tangent. And it's not that bad to do. 1 period's easy, right? So, gonna have some of these. Some of these. Now, something I see in the homework questions is they like to ask you this. So they like to say, they like to ask, what do they like to ask? 2 questions. Number 1 question, let's see. What x values make like y equals a tan bx 0? They like that question. Or they could say, intersects the y-axis, no, x-axis. That's the same thing. They like that question. And then the other question they like is what x values make y equals a 10x. Well, not make it. For what x values does y equals a10 bx have an asymptote, have vertical asymptotes? All right, and so just to be clear, here's how you would do that. So you would say vertical asymptotes. Those are the places that are at the odd multiples here, right? That's here. We already wrote those down once, okay? So they're plus or minus 1/2 period. So they're plus or minus pi over b, right? So you calculate a period. So the period is pi over b, not 2 pi over b, pi over absolute value b, and then the vertical asymptotes are at x equals plus or minus 1/2 period, plus or minus 3/2 period, etc., right? 5/2 and so on. We already talked about that. But the other question was where, so that was number 2. Number 1 was where is it 0, right? So let's see. Where is y equals a tan bx equal to 0, right? Well, that's going to be where the numerator is 0, actually. Like if you think about it, like the original thing is sine over cosine. And so the asymptotes are the places where the cosine is 0. That's where a divide by 0 is. It's going to be 0 where the sine is 0. So when you say where is it 0, that would be where sine bx would be 0. Which is, where would that be? Well, that's 0. Normally, sine x is 0 at 0, pi, 2 pi, 3 pi, 4 pi. But here, where we got a b, you have, it's going to be plus or minus, well, 0 first of all, so I should write that, sorry. 0, and then plus or minus 1 period, plus or minus 2 period, plus or minus 3 period, and so on. And so if you look, compare these to these, and so all the odd, like 1/2, 3/2, 5/2 periods are vertical asymptotes, and all the even periods, like even 1/2 periods, if you'll call them that, 0 period, 2 period, 3 period, 4 period, those are where it's 0. So what we're looking at is the equivalent of where is this? That's an asymptote. Where is this? That's a 0. Where is this? That's an asymptote, right? So asymptote 0, asymptote 0, asymptote. That should be it's over there, right? But it just alternates between an asymptote and a 0. So you can find those values. So yeah, so let's do one real quick one of that. Example. Let f of x equal 3 tangent 4x. And I'm going to say for which x values is f of x equals 0. That's how I'll ask it, right? So pretty straightforward. You need to know the period. So calculate the period, which is pi over b, absolute value, so it's pi over 4. All right. Now the zeros are at x equals 0, period, plus or minus, period, plus or minus 2, period, plus or minus 3, period, etc. So what are they? X equals 0, plus or minus pi over 4, plus or minus 2 pi over 4, plus or minus 3 pi over 4, dot, dot, dot. And so a lot of times on the homework, right, they'll have a list and you just check the ones that are what you're looking for on the list. Okay. Now if I just ask the other question, right, like let's say that this was part A, so let's say this was part A, and then there's also a part B that says for which x values does f of x have vertical asymptotes. Right? And then it would be exactly the same work, but it would be x equals plus or minus 1/2 period. I'm just going to write p for period. 1/2 plus or minus 3/2 3/2 period plus or minus 5/2 period, dot, dot, dot. So they would be plus or minus 1/2 of a period. What's a period? Period was pi over 4. Plus or minus 3/2 pi over 4. Plus or minus 5/2 pi over 4, dot, dot, dot. So if you work those out, right, they're plus or minus pi over 8, plus or minus, you work this one out, it's 3 pi over 8, plus or minus 5 pi over 8, dot, dot, dot. So if you compare these, if you compare the two sets of x values here and here, then you see that they're just kind of alternating. Like you have 0, and then pi over 8, and then pi over 4, and then 3 pi over 8, and then pi over 2, and then 5 pi over 8. Like that's how they increase in magnitude. So they just alternate between them, and if you marked them on the axis between asymptote and 0. Okay, so we did that. I think what we're going to do now is we are going to look at the cotangent, and then if necessary, we are going to if necessary, then we're going to do it with phase shift. Sorry about that. Talking hard. All right, so let's do this. Let's look at cotangents a little bit. Cotangents. Specifically, let's look at y equals cotangent x for starters. Now, cotangent x is an upside down tangent, so it's cosine over sine instead of sine over cosine. Okay, so that means everything is basically reversed. So what's going to happen when you look at it, I'll draw a picture and then we'll talk about the picture. Not like that. Go on the line. Okay. 0, 1, 2, 3, 4. Pi. 1, 2, 3, 4. 2 pi. All right, one more. Negative pi. Okay, so let me draw a cotangent here. So we're still going to have asymptotes, and in between the asymptotes, it's basically the same. You got a 0, 0, not 0, 0 actually, but you got a 0, and then one side is going to be up here, one side is going to be down here. And if you connect the dots, does this, right? And then everyone looks the same, just like these always work. And then the other one same picture. All right. So that's the basic graph of the cotangent. Okay, and so the x and the y values for the cotangent are a little bit different than the ones for the tangent. What they do is, first of all, so what we want are different x values. So it goes 0, quarter period, half period, 3/4 period, 1 period. Okay? And then the y values go d and e. That's here at 0. I don't know what I'm doing. Why did I? That was a meaningless scribble. So the first x value is right here. So that's an asymptote. The next x value is right here, so that's up at 1. The next one is here, so that's at 0. Next one is the third one, so that's at -1. And then you've got here, which is another asymptote. Right? And that's because the asymptotes here are, there's a v asymptote when sine x equals 0, right? Because you're dividing by 0 then. So that's the basic picture there. So it's exactly the same idea as the tangent. It's just a little bit different because the asymptotes are in slightly different places, right? 0 and pi for the basic one. Oh, actually, hold on. I need to just erase this. This was supposed to be generic, right? So I shouldn't have been referring it to a period. This should have been at specifically pi over 4, pi over 2, 3 pi over 4, and pi. Sorry about that. We'll switch to periods in a second, right? The point is that this first point is 0 and the last one is pi, versus the tangent, which was up here, where it was negative pi over 2 and positive pi over 2. All right, so let's talk about how you would plot the cotangent if you have this. So if you want to plot y equals a cotangent bx, right? Again, you're going to calculate the period. So you're going to want the period, calculate period, and I'm going to call it p this time formally. P equals, and it's 2 pi, nope, it's not, right? Pi. Pi over the absolute value of b, just like tangent, okay? And then you're just going to fill out one of these tables. So in your table, you're just going to have x and y equals a cotangent bx, but all you're going to have is 0, that should be a quarter p, half p, 3/4 p, and that should be p, but I was writing a pi, p. Okay. And then remember how this goes. Does not exist because that's a vertical asymptote. At p, that does not exist because that's a vertical asymptote. And in between, it actually goes so up high, 0, down low. So that is here, a, 0, minus a. That's how those go. All right, and we can summarize the information too. We can say that, so y equals a cotangent bx has, what's it got? Has vertical asymptotes at what x values? Well, 0, right? Because I can see right there. The next one is at the period, right? So that's going to be plus or minus period. Next one's going to be plus or minus 2 period, plus or minus 3 periods, and so on. I just started writing pi's instead of periods because that's what the period is for the normal one. P. All right. Vertical asymptotes there. Now, so vertical asymptotes there. But they also might ask you where it equals 0. So y equals a cotangent bx has zeros, or they might refer to that as intersecting, where it intersects the x-axis at, well, you can see one right here, right? 1/2 period. So that's at plus or minus 1/2 period, plus or minus 3/2 period, plus or minus 5/2 period, etc. Now, if you take a look at this information that I just have here, and you compare this with what we had for a tangent up here, you're just going to see that this is reversed, right? So a tangent had zeros at 0, plus or minus period, etc. Well, that's where the cotangent has vertical asymptotes. So they're reversed in terms of where they have vertical asymptotes and where they have zeros. Okay. And yeah. All right. So let's plot one. See how that goes. Example. Plot y equals, I don't know, 2 cotangent. You know what we haven't had? We haven't had like any of these pi's here. Let's say pi over 3 x. We haven't done one like that. Let's do that one. Okay. So what are we going to do first? Try to plot that. We need the period. Find the period. P is pi over b, absolute value. So it's pi over 3. Now remember, you divide by a fraction, that's the same thing as multiplying by the reciprocal. So you have pi times pi over 3, that's 3. Okay, so there's your period. Now once you have that, we should be able to get one period plotted just by making a table. So make a table, sorry. All right, x, y. So what are we gonna do? Quarter period. No, we got 0. Start at 0. 0, then you have a quarter of the period, which is 3. Then you have a half of the period, which is 3. Then you have 3/4 of the period, which is 3. And then you just have 3. Then for your y values, what do they do? D and E, A, 0, negative A, D and E. So D and E, D and E, and then in between it's A, 0, negative A. So what's A? Is 2. 2, 0, negative 2. There you go. So we should be able to plot one period very easily. And if we need more periods, we can do it. So what do we need on the x-axis? We need to go up to 3. So let's just go like 1, 2, 3, 4, 5, 6. So 6 is going to be at 3 actually. 1, 2, 3, 4, 5, 6. It would be 6. Okay. So that's what I want to do there. Now for my x values, y values, I'm just going to go 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, good enough. So if you want to plot this and this, those are your asymptotes, 0 and 3. So those are your asymptotes. Now in between, we've got some points to plot. So we got 3/4, comma 2, 3/2, comma 0. So where's 3/2, comma 0? That's actually halfway in between. All right. Now 3/4 is hard to plot on here because I made every box is 1/2. So 3/4 is right here. So 3/4, comma 2 is up here. And 9/4 is actually halfway in there. It's down here like this. So those are those points. And then you connect the dots and there's one plot, right? So that's at 3/4, comma 2. This one down here is at 9/4, comma -2, and this right here is at 3/2, comma 0. That's 2, comma. Okay. So there you go. And then if you need to plot it again, like another period of it, you just come over here, you put another asymptote, same distance away, and then you just copy the way it looks. Like that. Now, if you want to try to figure out like where this point is, like where is this point here, right? Like what are the coordinates right there? Well, what you could do is make sure you understand what a period is, because one period is how far you go before the graph repeats. So like this distance is one period, right? That's one period. So if I wanted to know what that point is, if I knew that this point was at x equals 9/4, right? And I wanted to know where this one was, that would be 9/4 plus 1 period, which is 9/4 plus, what was 1 period? It was 3. So 3 plus 9/4, and that would give me that x value. So that would, I mean, it's a little bit of trouble, right? 12 over 4, 12 plus 9, 21 over 4, something like that. Something like that. But you can calculate it if you have to. If you have to. It's a little bit tedious, but you can do it. So yeah. So we plotted that. What else do we want to do? I don't know if they do phase shifts in this section. I hope they do not. Just checking. What I do see is more of this kind of stuff, so I want to go over that in slightly more detail here. So let's see. So fact. The tangent and cotangent graphs repeat after every period, right? So that means I don't want to plot it too big here, right? But if I have a bunch of asymptotes like this, right? Then in each section it's the same graph, right? In each section it's the same graph, just repeated over and over again. And so if you knew this, right? If you had this table, or rather, let's say this. So we know that for, let's say y equals tangent x. Now I drew a cotangent here. This looks like a cotangent, not a tangent. But we know that for y equals tangent x, that that's the original graph that I drew, that we had these values, right? I'm going to draw them again. Why wouldn't that draw on a straight line? X. And we had, what did we have? Negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. And this was d and e for the y value, negative 1, 0, positive 1, d and e, right? And so what we should know, I'm going to erase that, write it nicer looking. slightly nicer looking. What we know is we know where it's -1, where it's 0, and where it's +1, right? And so you would be able to say, so for y equals 10x, tangent pi over 4 equals 1. But tangent of pi over 4 plus pi also equals 1. Why? Because this is one period, right? One period away. And the graph repeats. Whatever it is at 1, you can move over one period, and the distance, and you get to the same point again if you move over one period. Like if you take a point here and you take a point here, that's one period. That distance, one period. That distance, one period. So normally the period is pi, right? So if you tangent of pi over 4 plus pi is 1. Also, tangent pi over 4 plus 2 pi is 1, and so on. And negatives as well. Also, tangent pi over 4 minus pi is 1. Tangent pi over 4 minus 2 pi is 1, and so on. And you can do that for any point. So we did that for here, but you would also be able to do that for negative ones, right? So if you knew that one of them was at negative pi over 4, would give you -1, then you could add pi, 2 pi, 3 pi, 4 pi, and you could find lots of other points where tangent was -1. Okay. Yeah. And the same idea goes for the cotangent. Also for cotangent x, right? If we got this table, x, y equals cotangent x, and you go 0, pi over 4, pi over 2, 3 pi over 4 pi, and you go d and e, and then you go, what is it? Not a, it's 1. 1, 0, -1, d and e, like that. And then if you wanted to list all x values where cotangent x equals 1, they would be pi over 4, pi over 4 plus or minus pi, pi over 4 plus or minus 2 pi, etc., right? Forever. If you wanted to list all x values where cotangent x equals -1, you would start from this one and say, well, that's 3/4 pi, and then add or subtract pi, because that's one period. So 3/4 pi plus or minus pi, 3/4 pi plus or minus 2 pi, ... forever. So you can find as many of those as you want based on moving over by pi in either direction. And it's all because of this picture, right? One period gets you over to the next, like the next graph that looks just like the graph you're on. So you got some of those on the homework. All right, graph. They want you to graph 5 sine. That's easy. Easy peasy. We already did it. Oh no, they want phase shifts. I was hoping they wouldn't. They do. They want phase shifts. Right? So if you've got one of these with a phase shift and all that stuff, right? Plot y equals a tangent bx minus c plus d, then now you've got to deal with all the same stuff that you did for the sine and the cosine. All right, so Well, not amplitude, but some of the other stuff. Phase shift you have to deal with, and vertical shift. So, it's annoying, but you got to do it. So, what are we going to do? If you're trying to graph this, first you're going to calculate the period. Right? Just like always. Period P is pi over B. All right, absolute value B. Normally you would kind of just go from there, right? That's enough to write your table, but you need the phase shift now too. Phase shift. The phase shift is still going to be, I'll say PS, and it's still C over B. That did not change. And now you've got your, it's not really called a midline anymore, but I'll call it like a vertical shift. You can call it a midline if you want, vertical shift. And that's just going to be D, right? The A is not the amplitude, but we know where it shows up in the table. All right, so how do we do this? What has to change when we add this phase shift and everything here? So A tangent BX minus C plus D. All right, so before it looked like this for a tangent, right? We did negative 1/2 period, and we did the negative 1/4 period, and then we did 0, and then we did quarter period, and then we did a half period, right? Those were the values before for tangent. Now, because there's a phase shift of C over B, you have to have the phase shift plus this. Phase shift. I say plus, but in this case minus. Phase shift minus phase shift plus 0, which is 0, or which is phase shift plus phase shift plus. So you just add the phase shift. So everything moves over left or right by the phase shift. That's what a phase shift does. Now, this is still going to be D and E, and this is still going to be D and E. We're still going to have the divide by zeros there. Now the Y values, normally they were, what were they? Normally the Y values for the tangent were negative A, 0, and plus A, right? I mean, you can look them up, but that's probably what they were. Negative A, 0, plus A. Well, we've got this vertical shift here now, this new thing. So you've got to add the vertical shift on to each of these. So D minus A, D, it's plus 0, but that's just D, and then D plus A. All right, and then and then you got your phase shift, which you already talked about. Phase shift, phase shift, phase shift, phase shift, phase shift. So basically, what we did is the green and the yellow in that table is what's new compared to how we plotted that when we first plotted it, which is here, right? That's a cotangent. I lied. Where's the tangent? Here's the tangent, right? Yeah. D and E, negative A, 0, positive A, D and E, and then you got your negative P, negative 1/2 P to positive 1/2 P. Back down here, same thing, but now there's a phase shift and we add that D on there, right? Let's try to plot one of these using this. So example, plot. This is off the homework. Y equals 2 tan 4x plus 2 pi over 3, already hate it, minus 1. All right, how are we going to do that? We've got to calculate all this junk. So number 1, let's get the period. Period. P equals pi over absolute value B, so that's 4. Okay, pi over 4. Next, phase shift. C over B. So C over B, what's C? C is negative 2 pi over 3. Remember to reverse the sign, whatever's there. Negative 2 pi over 3 over B, which is 4. What's that work out to? Negative 2 pi over 12, which is negative pi over 6. All right. 3, what do we need? Vertical shift. D is negative 1. All right, so we got these numbers, right? Now that we got these numbers here, we got the negative 1, we got the P is pi over 4, we got the phase shift is negative pi over 6, and D is negative 1. We should be able to make our table. Right, let's make a table. So our table, X and Y, just going to copy this. So we got the phase shift. Well, I don't want to write that. Phase shift minus 1/2 period. What's the phase shift? Phase shift is pi over 6, negative pi over 6. So negative pi over 6 minus 1/2 period, which is pi over 4. All right. Then we got phase shift minus 1/4 pi over 4. Then we got phase shift plus 0, which is just phase shift. So the phase shift is, what is it? Where is it? Negative pi over 6. Then we got negative pi over 6 plus 1/4 pi over 4. And we got negative pi over 6 plus 1/2 pi over 4. All right. Now for the y values, those are a little bit easier. D and E, those are our asymptotes. In between, we got D minus A, so minus 1 minus, what's A? 2. Minus 1 minus 2, so that's minus 3. Then we got D plus 0, that's negative 1 plus 0, negative 1. Last one, negative 1 plus A, which is negative 1 plus 2, which is 1. All right. Now, we got to add these up. I'm not going to go to Wolfram Alpha here. I'm just going to do it on my calculator. I do have a calculator that does fractions. You can use Wolfram Alpha or whatever. So I got, what do I got? Negative pi, oops, clear. Negative pi over 6 minus pi over 8, it looks like. Ooh. Negative 7 over 24 pi. That's a good value, right? Next one. Negative pi over 4 minus, it looks like, pi over 16. That's negative 5 pi over 16. Negative pi over 6. Shoot. That's just really pi over 6. Okay. Do not like these numbers. That's negative 5 pi over 48. Last one. Negative pi over 6 plus pi over 8. That is negative pi over 24. All right. Now, that is a little bit tedious here. Interesting. Okay. Yeah, I'm just looking at the computer. It's hard to draw this on the computer. But so if you're going to try to draw this graph, it's going to be a little bit hard to do. To put this, are those all negatives? Those shouldn't be all negatives, right? Yeah, I guess they should. Can we just move that over there then? Yeah, okay. So, yeah, it's a little bit rough to draw. Let's try this. I'm going to put this over here because it looks like all my x values are negative. Now, I mean, I don't know how you're going to get these in the right spot, honestly, if you're doing the homework. This is going to be rough here. So, I can put this point in the right place pretty easily. Negative pi over 6, negative 1. So, if I go like, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 there. And the farthest left I need to go is negative 7 over 24. Ugh, what is that? I mean, these values don't even make sense. Maybe I calculated this wrong. I don't know. All right, I'm not going to be able to do this actually. I'm not going to be able to draw these in like the exact right spot just because there's such ugly fractions here. But so I'm gonna not do that. What I am going to do is I'm going to draw it and label it, but it's not going to be nice. So what's going to happen here is I'm going to have to say, like, let's just draw this line in. That's not part of the graph. That's an asymptote. Negative pi over 24, right? That's this one. Okay. Now, way on the other side somewhere, we got this one, negative 7 over 24. So let's just say 6 boxes away. 1, 2, 3, 4. Oops. 1, 2, 3, 4, 5, 6. That's negative 7 pi over 24. Now, why did I use 6 boxes? Because this was negative pi over 24, and this was negative 7 pi over 4. So from negative pi to negative 7 pi is a distance of 6. That's why I did it. Right? So if I get those in the right place, then in between is actually easy to plot because I only need the values negative 1, 1, and 3 here. I only need these 3 values on the y-axis, and those aren't hard to draw. So we can just go like negative 1. I don't want that color. Negative 1, right? 0, 1, 2, 3. So if I want to get this in the right place, all I got to do is halfway in between here, right? This one, I should be at negative 1, which is here, right? That's this. Now, at the one on the left, I should be at negative 3. Oh, which I guess I didn't draw. So halfway in here, I should be at negative 3. That's down there. And then halfway here, I should be up at 1. And then there's my graph. Now, that doesn't look quite like our normal graph, right? Like our normal graph for a tangent or something is like 0's right here, and that's where the middle is. But that doesn't happen because we got a vertical shift on ours, right? Because, sorry, I'm trying to squeeze that. All right. That doesn't happen on ours because we have this vertical shift of negative 1, so the whole thing's down by 1. That's why this is here, down by 1. All right? And so this is hard to plot. My advice to you, if you're trying to plot this, is you look at your x values. Like I've got this one, this one, this one, this one, and this one. And those are hard to locate on the x-axis. The easiest one to plot is this negative pi over 6, right? So that's the one that I would move first. Move that middle point to where it goes. And then hopefully you'd be able to figure out the rest from there. It's just tedious. Now, one more thing, we're an hour and 5 minutes in. It's also 4:23 in the morning, but you guys don't know that, so it's okay. Let's plot one more, or talk about how you would do this for a cotangent, right? So this was for a tangent. Oops. This was for a tangent. So you could do all the same stuff for a cotangent. So I'm not going to derive it or anything. I'm just going to say plot y equals cotangent, a cotangent bx minus c plus d. Everything goes the same as far as this stuff. Okay. Yeah. I don't want to do that. I wanted to copy that. Hold on. I'll figure it out. Duplicate. Really? That's impossible. Okay. How do I do this? Copy. Stop. Work. Man. Life is hard, guys. Paste. Okay. Yay, did it. Okay. So, if you're trying to plot y equals a cotangent bx minus c plus d, you do all the same stuff here. Calculate the period, same thing. Phase shift, vertical shift, you have all of those. Okay. And then you want to take those and you want to apply them to the table, just like you did for the tangent. So your table for a cotangent used to look like this, right? It used to be 0, quarter period, half period, 3/4 period, 1 period. Well, now you've got a phase shift. So now it's the phase shift plus that, phase shift plus, phase shift plus, phase shift plus, phase shift plus. Everything just moves by the phase shift to the left or right. Then your y values, same kind of idea, right? Your y values used to be D and E, and then in between here, they went A, 0, minus A. Well, now everything is shifted up. So everything is shifted up by that vertical shift. So you have that D there. D, D, D. All right. So from there, you should be able to plot one of these. They are a pain. I don't know how you would, like I said, I don't know how you would get that in the right place. They don't let you. Oh, can you type in answers? No. Okay. Yeah, I don't know. I don't know about these. All right, let's plot one. That's going to be impossible. All right. Example, I'm just going to make one up. Plot y equals 2 cotangent 3x plus pi. No, pi over 4 plus 4. Why not? Okay. I don't know what the numbers are going to look like. Hopefully not too bad. Yeah, they'll be okay. So, what are we doing? We need to, number one, find the period. So the period is P equals pi over absolute value B. So that's pi over 3. All right, easy. Now the next thing you need is the phase shift. So your phase shift, PS, is going to be C over B, which is, what's the C? C is pi over 4 in this case, over B, which is 3. So that is pi over 12. All right. Ooh, that's negative pi over 12. So negative pi over 12. All right. Now the vertical shift is just plus d. So d is, what is it? 4. Right? So you calculate those things. Then we should be able just to make our table. X and Y values. So we got start with the phase shift. So you got negative pi over 12. Then you got phase shift plus, that's a 12, plus a quarter period. Period is, what's a period? Pi over 3. And then you got negative pi over 12 plus a half period. Then you got negative pi over 12 plus 3/4 period. And then you got negative pi over 12 plus 1 period. All right, and we'll calculate those in a minute. Then you got your y values, which are d and e at the beginning and the end. In the middle, what do they do? D plus a. So that's 4 plus, what's the a? 2. And then d plus 0, and then d minus a. So we got 6, 4, 2. Now for your x values, you got to calculate them again. So it's kind of a pain. Not kind of, it is a pain. But you got to do it. So we got, what do we have? Negative pi over 12 plus, oh, that's pi over 12. So that's actually 0. The next one is negative pi over 12 plus, looks like pi over 6. So that's going to be positive pi over 12. The next one's going to be pi over 6. And then the last one is going to be, what is it? I should be able to do it, but my brain is, bad right now. So negative pi over 12 plus pi over 3/4 pi. All right. So there we go. Let me just highlight these to make them easier to see. There, 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 there. And then we need D and E, 6, 4, 2, D and E. So those are our X and Y values. So let's try to plot this. So hard to get these in the right place, especially when you can't draw on the lines. I just did the same thing again, identically to last time. All right, there we go. Actually, this needs to be lower, doesn't it? Okay, so how would I do this? So let's call this negative pi over 12, and then this would be pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, and so on. Now, get your asymptotes in the right place. One of them is at negative pi over 12. The next one is at pi over 4. Pi over 4 is 3 pi over 12. So that's actually this one. All right, so you have those in the right place. Now in between, all we have are y values of 2, 6, and 4. So we need those in the right place. So let's see if we can do that. So we need, let's call that 2, call that 4, and let's call that 6. Then what we've got for our graph is we've got 0, 6. So that's actually right here. Then we've got pi over 12, 4. That's right here. And then we got pi over 6, which is 2 pi over 12, 2, which is right there. And then so connect the dots. Oops, it's kind of a little bit ugly there. like that. And that's what we would have for that. It's a little bit hard to draw these in the right place, to be honest, but if you get it wrong, it'll ask you to do it again, and then you could hopefully have nicer numbers. Like this one would have been easy on the computer, but the previous one where the numbers were like 7 pi over 24, like how are you even going to put that in the right spot? It's going to be tricky. All right, so we are 1 hour 15 minutes, so I'm going to stop this right now, upload it, and then sleep till noon. So see you guys tomorrow, I guess.